Today we are starting 11.1 Circles and Parabolas in Standard Form. This is the beginning of our Unit 11 section on conics. So here we go. You got this. Part A is about circles. We're going to go back and talk about circles a little bit. You may have hit circles in geometry, but we're going to dive in a little deeper. So a circle is a set of all points in a plane that are a fixed distance called the radius from a fixed point called the center. Okay. The equation of a circle in standard form is x minus h squared plus y minus k squared equals r squared. Okay. So what we need to note from here is that your center is going to be your h comma your k, and radius is just r, right? Not r squared, just r. So again, center is hk, radius is r. And if you're giving your diameter, you need to remember that diameter equals your radius divided by 2. Okay, so diameter equals your radius divided by 2. Another thing that you may need to recall is the distance formula. If I'm given the endpoints of my diameter, I can find my radius by finding the distance. So the distance formula, if we remember, of 2 points, the distance formula is d equals the square root of x, write that correctly, of x2 minus x1 squared plus y2 minus y1 squared. Okay, so keeping that in mind, if I'm given 2 points and I need to find the radius, I can easily find the radius by doing this. Okay, the other thing is if you're given 2 points and you need to find your center, that would be your midpoint, right? So remembering how to find midpoint. So if you need to find the midpoint, remember midpoint equals, and it's an ordered pair. So it's x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. Okay, so bringing back some previous knowledge, some prior knowledge, I think we have enough and you'll be good. All right, so let's start here. We're going to talk about graphing a circle. Okay, in order to graph a circle, you need to simply know the center and the radius. So the first thing we want to do is make sure that it's in standard form. So you want to make sure in standard form. In standard form, that means that on the left-hand side, or just with where you're, on the left-hand side, where your square binomials are, there's no numbers outside of the parentheses. I can talk. So keeping in that form of x minus h squared plus y minus k squared equals r squared. Okay, so we want to make sure it's in standard form. So looking at what we have here, we have x plus 2 squared plus y minus 5 squared equals 9. So there is nothing on the outside except for 1. Perfect. And I can simply make 9 into 3 squared. Bam. Okay, we are now in standard form. Step 2 is you're going to plot your center. Remember, your center is your h comma your k. So for this problem, our center is 2 and, well, negative 2 and positive 5. Okay, now circles are weird altogether. It's not a function, it is a conic, not a function. And so what we're looking at here is that the whole thing that we said about x as being a liar applies to both. So your x is a liar, x is lie, and so are your y's. Okay, and that's because if you go look at the original formula, notice how it says minus h and minus k. That means their original values were already positive. So if it's going to change from a minus to a plus, that means that my h had to become a negative, because the only way to go from a minus to a plus is by multiplying by a negative. Okay, so my center is actually at negative 2 comma positive 5. So I'm going to plot my center. 1, 2, and 1, 2, 3, 4, 5. Boom. Right? All right. Third step is to apply, use radius to plot 4 points. Okay, so we're going to use the radius to plot 4 points. So my radius, it's not 9, the radius is 3 because your radius is r, not r squared, but r. So if we have 9, that equals 3 squared, which means that our radius equals 3. Okay, so from my center, where'd it go? 1, 2, 3, 4, 5. So from my center, I'm going to go 3 units left, right, up, and down. So from here, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Now that I have all my points, I'm going to do my very best to make a circle. Now we all know that this is not my strong suit, so pretend that these are the most curvaceous. Oh, that one got away a little bit. Let's pretend we didn't see that. It's because it's going to get for us today. No, I can't even accept it. I thought I could lie to myself, but I couldn't. Oh, okay. That side makes up for the rest. All right, so that's it. That's how simple it is to plot a circle using the equation. All right, let's look at some more examples. So notice in this example that there's nothing being added or subtracted to my x's and my y's, and that's because it's a 0. So we're talking about, again, in 1, you want to think about this in standard form, right? So in standard form, this would be x minus 0 squared plus y minus 0 squared equals 4 squared, right? That's in standard form. So from standard form, I know that my center, my origin of my circle, center of my circle, I'm sorry, is going to be at the origin, 0, 0. And I know that my radius is going to be 4. So I'm going to go to the origin, 0, and I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then I'm going to do my best to connect. And there it is. Pretty simple, pretty straightforward when you think about it. You're like, oh, it can't be that easy. It is that easy, okay? So now you're going to do a little bit more work to get into standard form, and that is a-okay, all right? So let's look at what we have here. We have 4x squared plus 4 times y plus 2 squared equals 124. So step 1 is to get into standard form. In order for this to get into standard form, I'm going to have to divide both coefficients out, okay? Luckily, the coefficients are the same, so I just got to divide by 4. If the coefficients were different, then I would have to multiply by their least common, divide by the least common multiple in order to kind of divide it out. All right, so we're dividing by 4. So I'm going to divide everything by 4. And that's going to leave me with x squared. So I was going to write in standard form for you. That's going to leave me with parentheses x minus 0 squared plus y plus 2 squared equals 31. 31. Okay, 31 is going to equal the square root of 31. 31 is prime, but in order for us to plot, we're going to have to kind of use the calculator to get an estimated value. So I'm going to plug in the square root of 31, and I'm going to get approximately 5 6/10. Okay, I don't know why I did that part there yet. I wasn't on the radius, but I just got overexcited. So my center is going to be at 0, comma, -2, remembering that they're always the opposite. 0 doesn't matter, but for the 2, even though it looks like a +2, it's actually a -2, okay? And like we said here, to find our radius, we would take the square root of 31. Square root of 31 is not something we easily can plot, so we would use the calculator to find an approximate value, and that's 5 6/10, so a little over 5 1/2. So I'm going to go to 0, -2, and I'm going to go about a little over 5 1/2 to the left, to the right, up and down. So 1, 2, 3, 4, 5. A little bit bigger. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Okay, and 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 5. 5. All right, so now I'm gonna connect. So I'm gonna try to just do it in one. Oh, that's smooth. Yep, again, pretend, use your imagination. This is the world's greatest circle. It's hard to do on this little board, but that's the first part. So, yeah. Next, now what if I'm given information and it wants me to create the equation of a circle? Okay, so I can create the equation of a circle as long as I have everything that I need to be put into standard form. Remembering standard form is x minus h squared plus y minus k squared equals r squared. Okay, so our first formula, we know that the center is at 4, 2, and the radius is 6. I have everything. I have my h, my k, and my r. So I'm just going to plug it in. So we have x minus 4 squared plus y minus 2 squared equals r squared, which is 6 squared, which equals 36. And there we go. Boom. Bam. Okay. All right, let's try it. What if you don't have a whole number? That's okay as your radius. Same thing. You have your h, your k, and your r. So we plug it in, x. Now it's minus a negative, right? Plus y minus 3 squared equals 2 square root of 3 squared. Okay, so I'm going to clean this up. So we have a negative times a negative makes a positive, which is why this is x plus 2 squared plus y minus 3 squared equals, and I have a power, and I'm going to distribute that power to each factor. So 2 squared equals 4. Square root of 3 squared equals 3. So therefore we get 4 times 3, which is 12. So the equation of my circle is right there. Okay. All right. On to part B, vertical parabola. So a vertical parabola, as we're doing this, just pay attention to how we're saying things. I'm not saying quadratic. I'm saying a vertical parabola, and that's because we're talking about it in the sense of it being a conic. A conic, not a function. Quadratic is the function. Okay, so we're going to be talking about a parabola. A parabola is a set of all points in a plane that are equal distance from a fixed line called the directrix. So this is our directrix right here, okay? And equal distance from a fixed point not on the line called the focus. So this is our focus right here. All right, the equation for a parabola in standard form is y minus k equals plus or minus 1 over 4c times x minus h squared, okay? It opens vertically, up or down, right? So how do I know it opens up and down? So if it opens up, that means that you're going to have your positive, your plus, right? That's what we call a minimum vertex, okay? If it says minus, that's how we know we're going to be open down and that we're going to have a max vertex. All right, so let's talk about how to find each piece of this. So if I'm looking for my vertex is still going to be h comma k. Okay, paying attention to the fact that k and h both start off negative, so if they appear positive in the problem, that is why. Okay, then we're going to talk about how to find your focus. Well, before you find your focus, you need to find your c value. So this c right here in the denominator, so we need to find the value of c. In order to find the value of c, you're going to take 4c and set it equal to your denominator. Meaning if there was no denominator there, then you would take 4c and set it equal to 1. If there, so you're going to set it equal to the denominator value. Once you have your c, then now you can find your focus, because you cannot find your focus in your directrix without your c. So our focus equals an ordered pair, and that ordered pair is going to be comma our h value, h comma k plus c. Okay, and our directrix is going to equal a y, an equation, because it's a line, so it's going to equal y equals k minus c. All right, so simple math to find everything we need to know about this problem. So let's dive in. So here we have y equals 1/8 x squared, okay? So we're going to talk about whether it opens up or down. So notice here that we have a positive 1/8. Because it's a positive 1/8, we know that it's going to be opening up because our coefficient is positive, okay? All right, next, our vertex. Remember, your vertex comes from your h and your k. For this, our h equals, it's not there, so 0, and our k equals 0 because it's not there. So our vertex is going to be 0, 0. Okay, then we're going to find our c. Our c comes from taking our denominator and setting it equal to 4c. So our denominator is 8, and we have 8 equals 4c. We're going to divide by 4, so we know that c equals 2. Okay, your focus. Remember, your focus, we said, is going to be an ordered pair because it's a point not on there. So for your focus, remember, it's parentheses h comma k plus c. All right, and we have everything we need. We have h, we have a c. We have everything we need to find our focus. So for our focus, our h is 0, our k is 0, and our c is 2. So our focus is going to be at 0, 2. All right, our directrix. Our directrix is a line, so it's an equation. So we are going to be at y equals k minus c. Remember, for your directrix, y equals k minus c. So if I'm at k minus c, my k is 0. Let me write that with y equals k, and my k is 0. My c is 2, so therefore y equals negative 2. Okay, so y equals negative 2 is our directrix. All right, next is finding points to the left and to the right of your vertex. So we're going to find points to the left and to the right of our vertex, and we want them to typically be equal distance from there. So if I'm at 0, 0, I can choose any points to the left and to the right. I'm going to choose points that would be easy for me to divide by 8. So I'm going to use 4 because I know that multiples of 4 can be divided by 8, or possibly divided by 8, right? So we're going to use negative 4 and positive 4. Again, I'm going to choose point to the left and to the right. At negative 4, when I substitute negative 4 in, I'm going to have 1/8 times negative 4 squared. So that's 16 divided by 8 gives me 2. I already know that's 0, and the same thing here. Because parabolas are symmetrical, that means that typically these are going to be the same value if they're the same distance from 0, right? So, just to show you what we mean, 1/8 times 4 squared is going to equal 4 squared is 16. 16 divided by 8 is 2. All right. On here, I'm going to plot everything I have. My vertex, my focus, my directrix, and my 2 points. Okay. So I'm going to go to the origin, 0, 0. Then I'm going to go to negative 4, 2. 1, 2, 3, 4. 1, 2. Gotta go to positive 4, 2. 1, 2, 3, 4. 1, 2. And I'm going to do my best to connect. Okay. So there's my parabola. Now I'm going to plot my focus. My focus is at 0, 2. Go to 0, go to 2, and there's my focus. Okay. And then I'm going to plot my directrix, and my directrix is at y equals negative 2. Where y equals means that it's a horizontal line. And so here is my directrix. So directrix, focus, and vertex. All right, it's not too bad. Again, simple math, just putting it all together. Okay, so our second example, we have y minus 2 equals negative 1/4 times x plus 3 squared. Okay, so when we look at this, we want to pay attention to the fact that there is a negative. This negative tells us that it's going to be open down. Okay. A good thing to remember is that we're going to apply the negative to the denominator when we are solving for our c. Okay. Your vertex again, that's going to be your h comma your k. That's an h. So h comma k, we're going to look for our h. Our h is always with our x. If it's a positive 3, that means that it was a negative 3. Well, if it says plus 3, I'm sorry. Y minus 2 means that we have a positive 2 for our k. C, so we talked about C. C equals, C comes from your denominator set equal to 4 times C. So our denominator is negative 4. So negative 4 equals 4 times C. Negative 4 equals 4 times C. So C equals negative 1, right? So we end up with C equals negative 1. Our focus, your focus, remember the focus rule was, it's a point, so it's going to be h comma k plus c. So our focus here, our h, well, our h came from here. What do we have for h? We have negative 3. Our k comes from here. We have 2. So 2 plus negative 1 gives us what? Well, that's going to put our focus at negative 3, 1. Okay. Next is our directrix. Our directrix is a horizontal line. To find that horizontal line, it's going to be y equals k minus c. So our directrix here, it's going to be y equals our k value. Our k is 2. Our c value minus negative 1. That's going to give us a 3. So y equals 3. Okay, so we're going to go ahead and put in y equals 3. So I'm going to come over here to my table, and I want to choose points to the left and right of my vertex. So my vertex is at negative 3. Negative 3, 2. Now, I have to be able to deal with 4, so thinking of things to plug in, numbers to plug in, may not be as easy. The main thing is also you just want them to be equal distance apart, if possible. So I'm going to stay small. Let's see if we use negative 5 and negative 1, what happens. So I'm going to plug negative 5 in. So when I plug negative 5 into this, what do I get? Well, our y is going to equal, so your y in this case equals negative 1/4 times x plus 3 squared, and we're going to go ahead and add 2. So that's what the y is equaling. So when I plug in x into this, I'm going to expand from here. So we're plugging in -5 for x. So let's do it out loud. So we have -5 for x. So -5 plus 3 is going to be -2. -2 squared is going to be 4. 4 times -1 4 is going to be -1. -1 plus 2 is 1. So my y equals 1. Okay? Because they're equal distance from each other, that means if I know one, then I know the other. So if -5 is 1, it's 2 away from -3, then therefore -1 also has to be 1 because it's 2 away from -3. So you only have to do that evaluating once if you choose numbers that are nearby. And now I'm going to go ahead and plot everything that I have. So I'm going to plot my vertex. I'm going to go to -3, 2, 1, 2, 3, 1, 2. I'm going to, after plotting my vertex, I'm going to go ahead and put in my points. So -5, 1. So at -5, I'm going to go to 1. And at -1, I'm going to go to 1. And then I'm going to plot my, I'm going to do my very best to kind of follow it out. Hopefully it makes sense. So I'm going to go, and then I'm going to go, sorry. So then here, once I have this, I'm going to go ahead and put in my focus and my directrix. So notice that my focus is right here at -3, 1. And if you look, you can see that these are multiples of my C distance from my directrix with my focus. So here's my focus, vertex. This is this space right here. This is 2 times C. Then we're talking about distance. So, and then my direction is at y equals 3. So we have y equals 3. And that should be the graph. All right, so this allows us to, we're graphing excuse me, our vertex, graphing our parabola with just use of the equation and a vertex. And as long as you know a combination of 2 information, so if you know the directrix and the vertex, if you know your focus and your vertex, if you know any combination of 2 information, you can write the equation and we'll be able to graph by using simple math to find where things are. Okay, so there's something I want to point out with this problem is that when we did our C, notice I put -1. I just want to point out the fact that C is a distance, so it's going to be a positive. But the reason why I emphasize putting the -1 is that a lot of times when I tell you guys focus on whether it's a max or a min, on where your directrix and your focus should fall, it's overlooked. And so I just have learned to train students to treat the C as a negative. If it's negative, treat it as a negative, because then the math will tell you where your focus and your directrix will end up at. But I just want to be mindful of the fact that this is supposed to be a distance, and so therefore distance is always positive, right? So in reality, it's C equals +1, but I do this, is what I've learned, to help students pay attention to following the formula and the rules. So with your focus, that this 1 is telling you your focus, which is located along your axis of symmetry, is 1 unit from your vertex. Okay, so the C is telling me that my focus is 1 unit from my vertex for this parabola. So here's my vertex. I go down 1 unit, and there's my focus. Okay. I just want to kind of iterate that. And the same thing for your directrix. So therefore, your directrix is going to be 1 unit the other way. And that's where the line is going to come from. But again, it's distance. And then all your points along your axis of symmetry, it's going to be multiples of the C. So notice that when I'm right here, I am 2 times C away from my axis of symmetry. Coming right here, I am 1, 2, 3 C away. Coming right here, I am 1, 2, 3, 4. Didn't quite make, I don't think I did. 1, 2, 3, 4 C away. And so like finding that C value is telling you how equal distance things are from your axis of symmetry. Okay, so again, C is technically not negative. I just tend to do it for the formula so that you can follow through and not mess up on your focus and your directrix. Okay, but if you remember that focus is within your parabola, your directrix is outside your parabola, then you'll be able to understand that your real C value is going to be always the absolute value of whatever we get here. And the reason being is because it's distance. It's a measurement of distance, okay? Let's keep going. Okay, so I want you to pause for a moment and try this one on your own. So again, you're finding the vertex, the C, the focus, and directrix. You tell me if it's open and up. And then you're finding 2 points that are equal distance from your focus, with your vertex. Okay, and we are back. So we have y plus 6 equals 1 over 12 times x plus 4 squared. I'm looking at my a value here, and my a is 1 over 12, and my coefficient, and it's positive. So therefore, it's going to be opened up. Okay, we're going to have a happy parabola. My vertex again comes from my h and my k. My h is always with my x. My k is always with my y. So my vertex is going to be, and remember, it's the opposite, so it's going to be at -4 and -6. Okay, finding my c, that comes from the denominator. So my denominator equals 4c. So if my denominator is at 12, and 12 equals 4c, therefore c has to equal 3. Okay, your focus, again, you should have did your focus. It's a point, so it's going to be h comma k plus your c. So when I find my focus, I'm going to end up with, my h is still -4, and my k plus c, so I have -6 plus 3. It's going to put me at -3. And your directrix, it's a horizontal line, so we have y equals k minus c. I don't know what happened to the line here, but my directrix is going to be y equals, my k value is -6, my c value is 3. -6 minus 3 puts me at -9. Okay, over here I have my center of my table is going to be -4, -6, and I want to choose 2 points that are equal distance from here. That would be good points to plug in. So a good way of thinking about it is if I use my my C. So if I use my C, what points could I use on following the rule of what my C is helping me with? So if C equals 3, I could go 3 units to the left, 3 units to the right, and then keep going to find another point that would be easy to plot. I would double that. So then I could go 6 units to the left, 6 units to the right. However you want to do it, it's still gonna, the math is gonna math, and we'll see how it works. For the sake of this, I'm gonna go ahead and do both so you can see what I'm saying. So if I go 1C, That's going to put me at -4 going to the right. So -4 plus 3 is going to put me at -1. And then if I do another C value, so plus another C value, that's going to put me at 2, right? Now going the other way, subtracting a C value, so -4 minus 3 is going to put me at -7. -7 minus another 3 is going to put me at -10. Okay, remember I'm plugging these values in for y, so if I wanted to get y by itself here, it's going to look like 112 times x plus 4 squared minus 6. So when I'm looking at numbers to plug in, I think I would rather go with the smaller numbers. So I'm going to do -1. So if I substitute -1 in, -1 plus 4 is going to give me 3. 3 squared gives me 9. 9 twelfths gives me a fraction. And I don't want to deal with the fraction. So I'm like, we're not going to do. Okay. So now I can do 2. Let's see what happens with 2. So I'm going to plug 2 in. I get 2 plus 4 is 6. 6 squared is 36. 36 divided by 12 gives me 3. 3 minus 6 gives me -3. So I'm like, oh, that one works way better. Okay. And because they're equal distance from my vertex, I know that this is still going to be a decimal value that I don't want to find, but I know that this is going to be -3. Okay. So your C value is a way to distance yourself, to figure out how much I should go. So this was 1 C away, this was 2 C away. Then we would have 3 C away, and then we have 4 C away. Okay. So I'm going to plot what I do know and what I am using. So just to emphasize, I'm plotting 2, -3, -4, -6, just because they're easy to plot by myself. Okay. So I'm going to go to -4, -6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So here's my vertex. Okay. From my vertex, I know that my C is 3. So I know my focus and my directrix are going to be off of this axis 3 units. One's going to be 3 units up and the other's going to be 3 units down. So 1, 2, 3. This is going to be my focus because my focus is inside my parabola. And 1, 2, 3 coming down. This is going to be my directrix. Okay. And that's because my directrix is outside of my parabola. It's going to be y equals. And it said we were going to be at -9, and guess what? We are. My points that I'm going to plot are 10, 10, -3. So 4, 5, 6, 7, 8, 9, 10, 1, 2, 3. And then 2, 3, -3, -2, -1, 0, 1, 2, 1, 2, 3. All right. And now I'm going to do my best to sketch this out. It's going to go slightly off, so hopefully yours should too. Oh, that did not go very well. Let's try that again. That went fairly decent. Okay, and there is my problem. All right. Part 3 is a horizontal parabola. With your horizontal parabola, it's going to be the same thing that we just did with a vertical parabola, except now we are facing either left or right, and we're going to have to determine whether it's going left or right. Other than that, there's no difference. So here is our horizontal parabola. So with our horizontal parabola, this is our equation. So notice that the square, the power is with the y, not with the x. The power is with the y. That is how you know whether you have a horizontal or a vertical parabola. Where is your power? My power is with the y. So y has the power here. Okay. On a vertical, x has the power. and we're going to determine whether it opens left or right. How do I know if it's going to open left or right? I'm going to look at the value of my coefficient. So notice here, I have a plus or minus. So when I have a minus, so if I have a negative coefficient, that's going to cause me to open to the left. Okay. If I have a positive coefficient, that's going to cause me to open to the right. Kind of makes sense, right? What numbers are to the left? Negative numbers. What numbers are to the right? Positive numbers. Okay. So keeping that in mind, that's how we determine whether it's going to be open left or right. Now we're going to look at our features, same concept as features. So when we look for our focus, vertex, I said that backwards, vertex, focus, directrix, it is still following the same rules, except now it's in terms of x, okay? So our vertex, our vertex at this point is now going to still be HK. Nothing changes in that sense. H is still with X and Y is still with K. In regards to that, that keeps it easy, keeps it simple, and they both are still liars. Okay. Now for our focus. So for our focus is going to be now on our horizontal axis of symmetry. So K is going to stay constant, and we're going to have H plus C, and K is going to stay the same. Okay, our directrix again is now going to be vertical instead of horizontal, so it's going to define by x equals, and it's still H minus C. Meaning that our focus is still on the inside of our parabola, and our directrix is on the outside of our parabola. Okay, now if we follow this, we can just go find our values that we're going to use. We're going to stick to finding 2C, 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 C, C, C. Okay, and again, C still comes from your denominator. All right, so here we go. So first up, we have x equals 1/8 y squared. Okay, we're going to determine whether it's going to open left or right. Why? Because y has the power. Okay, so that lets us know that we have a horizontal situation. So this is positive, so therefore it's going to open to the right. There's x and y are not being added. Nothing's being added or subtracted to our x and y, so therefore our vertex is at 0, 0. So h and k are 0, 0. Our c is from our denominator. So if my denominator is set equal to 4c, so we have 8 equals 4c. Therefore, c has to be 2. Our focus is going to be along our horizontal axis of symmetry, which is based off of our k. So when we're looking at our focus, we know that it's going to still have the same k value, but our our x value, same y value, but our x value is going to change. So that's because our focus is h plus c, because it's a horizontal. And so we're going to have 0. So our focus is 0 plus 2, which is just 2. So 2 comma 0 is going to be our focus. Our directrix is on the outside, and we are subtracting, and it's going to be a line, but a vertical line, so it has to be x equals, and it's going to be x equals h minus c. So for our directrix, our h is 0 minus 2 is going to put us at x equals negative 2. All right, for our table, we're going to find values that are equal distance from our origin, which is easy when it's 0, 0. For me, I've learned that I think it's just easier to go 2c out. So if I go from here to here, double my c value, from here to here, double my c value, right? So 2c would put me here at 2, right? And then same thing is going to be here. Okay, notice that these values are the same this time. Why are they the same? Because it's a horizontal. So your x's are going to be the same, but your y's are going to be different. I went backwards, y'all. That was wrong. I went the wrong way. I'm treating it like a vertical. You saw nothing, you heard nothing. And I'm not going to start this over, so. Wrong way. 2c, 2c. Okay, 0. So 2 times t is 4. So I'm going to go left 4, or up, down 4, down 4, and then up 4. There we go. Ta-da! Fixed it. Now we're going to plug in and solve for our x. So when I plug -4 in, I'm going to get 16, right? Right here. Plugging -4 in for y, we get 16 divided by 8, and that's going to give us 2 because they're equal distance apart. That means that this is also 2. Now I'm going to plot everything. So my vertex, 0, 0. I'm going to go to 2, -4, and 2, +4. So 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. And that's not very symmetrical. We're going to pretend that it is. Our focus is at 2, 0. So I'm going to come, and I know it's 2, 0 because it's going to be 2 units from my vertex. 2 units in. 1, 2. And that is my focus. Now I'm going to go 2 units outside of my parabola. 1, 2. And that is going to be where my directrix lies. My vertical directrix. And that's at x equals -2. All right. Let's look at another. So here we have x minus 2 equals -1/4 times y plus 3 squared. We're going to look at our leading coefficient here. And our coefficient is negative. So because our coefficient is negative, that lets us know that we're going to be open to the left. So we're looking, our parabola is going to be like this. Okay, your vertex is still based off of your h and your k. So our h is 2, our k is -3. So here's our h and here's our k. Your c comes from your denominator. Remember, c is going to be technically positive. So just remember how it is affected here. So here we go. So if we have a -4 and it equals 4c, then we're looking at c equals -1, but we're going to take the absolute value of that, 4c, right? So this is going to be the absolute value of c, and the absolute value is 1. Your focus using this c, your focus is going to be your h plus your c, comma, your k. Your directrix is going to be x equals h minus c. All right, so our focus, our h is 2. Our c is -1. So 2 plus -1 equals 1. Our directrix, it's x equals. Our h again is 2. Our c is -1. So that's going to give us 2 minus -1, which equals 3. So now we can write everything out. So we know that our focus is going to be at 1, comma, -3. And our directrix is at x equals 3. Okay. On our table, our vertex is at 2, -3. And again, this time, this is your independent. So this is what we're leading from. I'm going to do 2c. C. So my c is 1, 2. So 2 to the bottom and 2 to the top. So -3 minus 2 is going to put me at negative, am I negative 3? Yeah. Negative 3 minus 2 is going to put me at negative 5. No. Negative 3 plus 2 is going to put me at negative 1. Doesn't matter which one I plug in, but I'm going to plug it in for the y. So plugging in for y, let's do it out loud. So I'm going to plug in, let's do negative 1. Negative 1 plus 3 puts me at 2. 2 squared is 4. 4 divided by 4 is going to give me 1. 1 times 1 is negative 1. My x is not by itself. In order to get by itself, I'm going to have to add 2, right? So that's going to put me at 1 plus 2 is, no, where was I at? Negative 1 plus 2 is 1. If you couldn't do it out loud, what we did is we had to get x by itself. So what we plugged in was x equals negative 1 over 4 y plus 3 squared plus 2. And all I did was plug in the negative 1 here and go through evaluating using PIMDAS. And we get 1 and 1. I'm going to go to 2, negative 3, 1, 2, and I'm going to go down. 1, 2, 3. That is going to be my vertex. For my vertex, I know that I'm going to go 1 unit up, and that is going to be my focus. I'm going to go 1 unit down, and that's going to be my directrix. X equals 3. Okay, then I'm going to plot my points. I'm going to go to 1, and at 1, I'm going to go to negative 1, and then I'm going to go to negative 5. And those are going to be my points that I use to hopefully sketch to the best of my ability. I'm going to stop right there, and there is my left. So there are 2 more for you to do. So at your tables, I want you to go through and do 3 and 4, talk it out with each other, and we'll go from there. All right, let's see how we did on 3. So for 3, I'm going to kind of just go through what you should have gotten at your tables. And yeah, so looking here, it's positive, so you should have said that it opens to the right. Your vertex, your h and your k should have been at negative 1, comma 2. Your C value, what multiplies by 4 to give you 12, you should have gotten 3. Your focus should have been at 2, comma 2. And your directrix should equal x equals negative 4. On your table, if you're plotting your points, so I know I'm at negative 1, 2. And then for my y values, I used 8 and negative 4. They were 2c away from my the y value of my vertex. When I plug that in, I got 2 and 2. So now I'm going to plot everything. So I'm going to go to negative 1, go up 2. There is my vertex. From my vertex, I'm going to go to the right 3 because it says I open 3, and that's where my focus is going to be. 1, 2, 3. Here's my focus. Now I'm going to go left 3, and that's where my directrix is going to be. 1, 2, 3. And that's where my directrix is at x equals negative 4. All right, then I'm plot my points. I'm going to go to 2, 1, 2, and I'm going to go up 8 and then go up to 8 and then go down to negative 4. So from here, it's going to be 6 units. 1, 2, 3, 4, 5, 6, because I went double my C value, which is 3, and 3 times 2 is 6. I'm going to go 1, 2, 3, 4, 5, 6. And I have a pretty wide parabola opening to the right. Okay, that's what your 3 should have looked like. Let's see what. So on 4, you had a negative. So since you have a negative, you know that's going to be open to the left. Your vertex is still going to be based off of your h and your k. So your h here is 8. Your k here is going to be a negative 5. All right, your c is based off of here. And again, we're taking our denominator. We're going to say it's negative 8 equals 4c. So we know that c is negative 2, but here you want the absolute value of c, and that also applies for the vertical parabola. I'm sorry. So we get 2 for our focus. Our focus here, it's going to be, if you can't count from your vertex, I'm sorry, I had a little brain fart where I was like, what am I doing? If you're at your vertex, you can do it graphically also. I just want to emphasize here. So if you're struggling with like remembering things, just remember that your focus is inside, your directrix is outside, and it's going to be C away. All right, so if I'm at 8, negative 5, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay, so this is my vertex. My focus is going to be inside of my vertex, C distance away. So I open to the left. So if I go to the left, 1, 2, this is my focus. Okay, so from here, I know that my focus is going to be at negative 3, 5. Not negative 3, positive 3, negative 5. Okay, and then I'm going to go 2 units behind me, 1, 2, and this is going to be where my directrix is, right here on 10. So at x equals 10, that is my directrix. If you look here, all I did was, I said 3, that's a 6, y'all. It is 6 o'clock in the morning as I make this video, and we all know that I am not a morning person. Sorry, I didn't mean to write 3, it's 6, okay? So in comparison to this, so all I did was at 8, I subtracted 2. At 8, I added 2. That's your directrix, okay? So if you can't remember the formula, just kind of remember what's happening. Then on my y values, so we have 6, well, we have 8 and negative 5. So for my y values, again, remember, I'm just saying we're doubling our c. And so I'm going to go 4 units up and 4 units down. So if I'm at negative 5 plus 4, that's going to put me at my up, right? So negative 5 plus 4 puts me at negative 1. Negative 5 minus 4 is going to put me at negative 9. I'm going to plug these values in. I'm going to always use a smaller number if possible to plug in. So I have negative 1, and I'm going to plug it in for y. Negative 1 plus 5 is 4. 4 squared is 16. So we're plugging it in. So again, negative 1 plus 5 is positive 4. 4 squared is 16. 16 over 8 becomes 2. 2 times negative is negative 2. And I have to add the 8 because it's subtracted, right? So negative 2 plus 8 is going to put me at positive 6. So the values are 6 and they're equal distance. So this is also 6. You only have to plug it in one time because they're equal distance from your vertex, which means that their x values are going to be the same. Okay, so I'm going to plot 6, negative 1. So here, 6, go to negative 1, and then I'm going to go here, and I'm going to go down to go down 4. 1, 2, 3, 4, and plot. Okay, the other thing you can do is if you don't want to do the math, the fact that you know that your focus is going to be 2 4, I'm sorry, double your C. So in this case, from my 4, my C is 2. I can just go ahead and count 1, 2, 3, 4, 1, 2, 3, 4, and that can work the entire time. So that is your whole thing. Sorry this is long. I made this over a course of the night where I took a nap and woke up back early.